We see water every single day, right? But have you ever really stopped to think about its secret chemical superpowers? Well, today we're going to pull back the curtain on this everyday wonder. We're going to see how it pulls other stuff apart and then, like magic, rebuilds it into something absolutely beautiful. Crystals.
All right, let's dive in. Here's the game plan. We'll start with water itself, this everyday wonder. Then we're going to get into the art of dissolving, find out what happens when water just can't take anymore, see how a little heat completely changes the rules, and finally, learn how to get those amazing crystals back out. It's going to be fun.
So, let's kick things off with our hero molecule. I mean, it's so common we barely even notice it, but you could argue that water is the most important substance on the entire planet. And all of its superpowers? They come from a few unique, kind of hidden properties.
We see it all over the place, right? In its three states. You've got solid ice, liquid water in the oceans, and gas as steam or clouds. But the real magic, the action that makes life itself possible, that's all happening at a level that's totally invisible to us.
So what is its secret?
I mean, it's not just that it's wet. It really boils down to its molecular structure and its incredible, almost unbelievable ability to interact with and literally pull apart a huge range of other substances.
Yeah, this ability has earned it a pretty epic title, the universal solvent. And that's not just some cool nickname. Think about it. From carrying nutrients in your blood to carving out canyons over thousands of years, this one property is absolutely fundamental to life. It is the ultimate mixer.
Okay, so how does water actually do it? How does it perform this incredible dissolving act? Let's get into the chemistry and break it down.
So when something dissolves in water, it forms what we call a solution. And all that means is it's a perfectly uniform mixture. Just think about salt water. Once you give it a good stir, you can't see the little salt grains anymore, can you? It's all just one thing.
Now, in any solution, you've got two main players. First up is the solvent. This is the substance doing all the heavy lifting, the one that's actually pulling the other substance apart. So in our saltwater example, water is the solvent. It's the boss. And the other player is the solute. That's the stuff that gets taken apart and mixed in, like our salt. Just remember this simple little formula. Solute plus solvent equals your solution. Easy as that. But is there a limit? Can water just keep dissolving salt forever and ever? Well, the answer is no. And that limit is a really important idea in chemistry.
A solution can basically be in one of two states. If it's unsaturated, it's kind of like a dry sponge. There's still plenty of room to soak up more of that solute. But once you hit the saturated point, that's it. The water is totally full. Just like a drenched sponge, it literally cannot hold any more.
But, and this is where it gets really cool, you can actually trick water. By heating it up, dissolving a bunch more solute in, and then cooling it down very carefully, you can create a super saturated solution. It's holding way more than it should, which makes it incredibly fragile and unstable. The tiniest little bump can cause all that extra solute to instantly crash out. It's pretty wild to see.
We just mentioned that temperature is a huge factor, and believe me, it dramatically changes the rules of this whole dissolving game. So let's see exactly how that works.
So check out this graph. It's called a solubility curve, and it shows us precisely how temperature affects dissolving. The bottom axis is temperature, and the side axis shows how much stuff can be dissolved. Each of those colored lines, that's a different substance.
See that really obvious trend? For most of these solid things, like potassium nitrate or sodium nitrate, the line goes up and to the right. What does that mean? It means the hotter the water gets, the more stuff you can dissolve in it. Simple as that.
It's pretty much a golden rule in chemistry, and it's exactly why you use hot water to make sweet tea or hot chocolate. You can dissolve a ton more sugar in hot tea than you ever could in a glass of iced tea.
But, chemistry always has a few rebels. Take a look at the curve for this thing called Glauber's salt. Its solubility goes up with temperature, but only to about 32 degrees Celsius, and then it does the complete opposite. It starts to fall, becoming less soluble in hotter water past that point. How weird is that? Okay, so we've pretty much mastered dissolving things in water. But what if we want them back? Well, that's where the absolutely beautiful process of crystallization comes in. See, when a solute comes back out of a solution, it doesn't just reappear as a messy powder. If you do it right, its atoms or molecules line themselves up into this highly ordered, perfect, repeating pattern. And the result is a crystal, a solid with a definite and often stunning geometric shape. And you can totally do this yourself. It's exactly how rock candy is made. The process is pretty straightforward. You make a saturated solution with hot water, maybe filter out any gunk, and then, this is the important part, let it cool down super slowly.
As the water cools, it just can't hold as much solute anymore, forcing it to come out and build those perfect little crystals.
And here's the payoff. Look at these shapes. They are not random at all. A substance like table salt will always form little cubes, while other things form prisms or other cool shapes. This distinct geometry is like a fingerprint. It's a direct reflection of how its atoms are arranged on the inside.
Now, some crystals actually have water molecules built right into their structure, and how they react to the humidity in the air is fascinating. An efflorescent crystal is like something drying out. It literally loses its built-in water to the air and crumbles. A deliquescent crystal does the total opposite. It's so thirsty it sucks moisture out of the air until it turns itself into a puddle. And then hygroscopic ones are in the middle. They'll get damp but won't fully dissolve. And this brings us to a really important distinction. A drying agent, that's like a paper towel. It just soaks up loose moisture. But a dehydrating agent? Whoa, that's way more aggressive. It doesn't just soak up water, it chemically rips the H2O molecules right out of another compound structure, changing it completely.
You know, what this all shows is that from a simple glass of salt water to the formation of a perfect crystal, there is this hidden world of structure and rules and order. It proves that the most common things around us can hold the most profound secrets. And it really makes you wonder, doesn't it? What other invisible patterns are hiding in plain sight, just waiting for us to look a little bit closer?